The following parameters of the arrangement of figure 1.11 are available. The angle alpha which the inclined plane forms with the horizontal and the coefficient of friction K between the body M1 and the inclined plane. The masses of the pulley and the threads as well as the friction in the pulley are negligible. Assuming both bodies to be motionless at the initial moment, find the mass ratio M2 by M1 at which the body M2 starts coming down, starts going up and is at rest. So let's first draw the forces that are operating here. So the weight of this object M1 is M1G, that will act in this direction, and its component along the inclined plane is mg sine of alpha, and its weight, another weight component perpendicular to the plane, is mg cos of alpha. Here T is the tension in the string, T is the tension in the string, and M2G is the weight here. Clear? Now when this block, according to the condition A, when this block starts coming down, this M2 block starts coming down, in this situation the force of friction will be in this direction. The force of friction will be in this direction, and in this situation we can write that this T is greater than the sum of these two forces, and here M2G is greater than this T. So we can write for A part that T must be greater than M1G sine of alpha plus force of friction, and that will be Km1G cos of alpha. And for this block of mass M2 we can write that M2G must be greater than T, only then this block will come down, M2 will come down and M1 will move up the incline. And if we combine these two situations, so from here we can write that this situation is possible. So M2G is greater than M1G sine of alpha plus K cos of alpha. Or from here we can write that M2 by M1 must be greater than sine alpha plus K cos alpha. Clear? So if this ratio M2 by M1 is greater than this value, only then this block M2 starts coming down. Now for part B, when the block M2 starts moving up, now in this situation the force of friction will be in this direction, cause this block M1 will be moving in this direction down the inclined plane, and friction will be in this direction. Clear? So in this situation we can write that if M2 is going up and then M1 is coming down the incline, so this is possible if M1G sine of alpha is greater than Km1G cos of alpha, the friction force, plus M2G. Or from here we can write directly, following the above situation, that M2 by M1 is less than sine of alpha minus K cos of alpha. So if M2 is coming down, this is only possible when M2 by M1 ratio is less than this value. Clear? Now for situation C, he is saying that the block M2 is at rest, means neither of the condition is allowed, means the situation here is intermediate between this value and between this value, means here neither the block is going up nor it is coming down, so the situation must be intermediate, and hence for this situation we can write that M2 by M1 is less than sine of alpha plus k cos of alpha, and this M2 by M1 is greater than sine of alpha minus k cos of alpha. So we have standard situations that if this ratio is greater than this value, only then this block will come down and this will move up the incline. If this ratio is less than this value, then it will move up, this will come down. And for this situation we can say that the force of friction is not reaching up to the limiting value, and hence the system will remain at rest.